All right, today we're starting chapter 6, section 1, algebraic expressions and formulas. First thing we're going to talk about is what's the difference between an expression and an equation? What do you think the difference is? What do you think an equation has? Yeah, equation has to have an equal sign. Expression, no equal sign. And whenever you look at the homework assignments or the end of the section assignments, what you'll see, there are words associated with expression and equation. Whenever you have an expression, the only thing you can do is simplify it. Combine like terms. That's all you can do. When you have an equation, you solve. So the simplify is combining like terms. Combine like terms. I know it's getting smaller there, I'm sorry. And solve, we're not done until the variable equals some number. So in this one, this is an equation. It's an expression because there's no equal sign. It has a variable, but there's no equal sign. We're saying we're defining what the variable is. There are two types of variables. Okay, first off, what's a variable? It's usually a letter. It can't be a number because a number is a constant. It stays that number. But it's a letter that can be any value. Hence, variable. It varies. It changes. So when I say there are two types of variables, the first one is called the independent variable. It's an independent variable. Can be anything. You can pick any value you want to and put it in that variable. So what's the opposite of independent? Yep, the second one is called a dependent variable. A dependent variable only gets its value oops, I ran out of space. The dependent variable is a variable that only gets its value once the independent variable is chosen. So a dependent variable only gets its value once the independent variable is selected. So. Let's say we had an equation here, y equals this. So do we know the value of y? No, we don't know it because we have an equation here. We don't know what happens until we define what x is. That x is the independent variable. We can put any number. Here, we're defining what it is. We're defining x is 6. So once we define the independent variable, we plug it in there in place of x and work it out. And the value of y will be determined once that's worked out. So work it out. What do we get? What's my first step?
You subtract 9 minus
9.
6
Six.
minus 4.
Yes, we do inside the parentheses first. Order of operations. Do special operations first. So we have to do inside the parentheses first. 6 minus 4 is 2. Every time you do something, repeat it. Okay, we have a parenthesis. Can we do anything inside the parenthesis? No, that's just 2. So what's the next thing we can do? The next thing are exponents. We do that. What is 2 to the 3rd power?
8.
Very good. It's 2 times 2 times 2, which is 8. Repeat the process, special operations. There's parentheses, can't do anything, there's no exponent. So what's the next thing we do?
Times 8.
Yeah, do the multiplication. Because multiplication is more important than addition. So we do that. What is 5 times 8? So there's the value of y. So that's what they're having us do in this first set. Let's go to the end of the section and just do problems. I know you've seen this stuff before. It's just, let's put names and reasons behind it. Let's do let's do 32 and 33. (32) is negative x squared minus 3xy plus 4y to the 3rd power. When x equals -3 and y equals -1.
See, I don't know why. I always got confused with these back in high school. First, because I couldn't get it. It was like, I couldn't get it.
So anywhere you see an x, what do you put in its place?
You see next to put -3.
So here's an x. So since it's negative, I put a parenthesis around it. Here's another x. I put a parenthesis around that. What's y?
Why?
So anywhere we see a y, we put a -1. I'm not like, well, when I first saw this back in high school, many decades ago, same thing. Didn't make any sense. And then once I started working on it, it's, yeah, it makes sense now. So pretty much anywhere I see an X, I just put a -3. And you see a Y? So that's what I did there. Then the next thing, what do you do?
I would say.
Here's the order of operations. Very good. The first thing you do are always special operations. By special operations, parentheses, bracket, exponents, absolute values, square roots, and so on and so forth. You do anything that looks weird. After all those are taken care of, then you do multiplication and division, and then addition, subtraction. As you read from left to right. Now, there's another thing I have to review with you before we do these. Exponents and negatives. What's the difference between this and this?
It's the one from the.
Well, let's look at the X, the negative. A -2 is the same thing as -1 times 2. So this is multiplication, this is exponent. Which one do you have to do first?
You have to do.
The exponent. The exponent, you have to do it first. So 3 to the power 2 is? Yeah, because this would be 9. The negative stays out there. And 3 squared is 9. So the answer is -9. But this one,
Doesn't it turn to a positive?
because what we have here is -3 times -3. It's whatever's under the power. So negative is a positive. 3 times 3 is 9. So it's a positive 9. And how about this one?
-9, because the negative's outside.
Exactly. Very good. Because this negative is outside, it stays there. This becomes 9. So its answer is -9. Very good. I wish I had more space. Well, we'll come back to this guy in a little bit. Because I have some more rules I'm gonna put. So we discussed here that those two. How about the difference between these? Exponents and signed numbers. What's the difference between all 4 of these?
It would be.
Yeah, because this one is -3 times 3, which equals -9. Very good. Because it's -3, -3. Very good. And this one? Well, the negative is out in front. 3 times 3 times 3. Right, still gonna be negative because it's outside, it's in front of the 3. What is 3 times 3 times 3? Do your fingers, 9 times 3. Very good. -27. And what about this last one? It's, since it's inside parentheses, it's -3 times -3 times -3. Is the answer positive or negative? No, because negative times, it'd be negative. 3 times 3 times 3 is. Interesting. What did you notice? If the negative's out in front, it doesn't matter what the exponent is. But if the number's inside the parentheses and it's negative, if the exponent is even, the answer is always going to be positive. If the exponent is odd, it's always going to be negative. These are for numbers in with the negative inside the parentheses. So don't work it out. Just, is that going to be positive or negative answer? Yep, because it's an odd number. So it'd be 5 to the 7th. But it would be negative, right? So that's what we have to cover first. Let's now finish up that question we were working on originally. This was number 32. -x² minus 3xy plus 4y² when x equals -3 and y equals -1. So there's a negative. The x, since it's negative, I put in parentheses to the power 2 minus 3. X is -3, put in parentheses. The y is -1, put that in parentheses. Plus 4 times -1 to the power 2. Now, what do you do next? Yes.
So it would be,
This is cubed, I'm sorry.
so first one, it would be -9. Negative.
Very good. Very good.
The one.
This one? Or this one? Right, but it's negative, negative, negative. Since there's an odd number of negatives, it's negative. 3 times 3 is. Yeah, 9. 9 times 1 is 9. Plus 4. And then -1 cubed is. Very good. Because we know it's negative because it's cubed. 1 times 1 times 1 is 1. So that got rid of the exponents. What's the next thing we do? So we have -9 minus 9. So remember, I always tell you guys, treat the numbers and the signs different. So positive times negative is negative. And then 4 times 1. So if you're multiplying, if the signs are the same, it becomes a plus. If the signs are different, it becomes a minus. It would be what? Is it gonna be positive or negative? Nope. This only works when you're multiplying. So this is, if I think of a number line. -9, that means I go left to -9. -9, which direction am I going? To the left or to the right? Remember, left is negative, right is positive. I still go to the left. So, right. So remember the rule I talked about a couple weeks ago. If you're adding and subtracting, if the signs are the same, keep the sign and add the numbers. So 9 plus 9 is 18. So let's put that rule down. Adding, subtracting rules. 1. If the signs are the same, then take the common sign and add the numbers. Then the second rule, if the signs are different, then take the sign of the larger number and subtract the numbers. By subtract, I mean larger minus smaller. So that's what it is here. Here, we're adding and subtracting. So the signs are the same. We keep the sign, add the numbers. Same thing here. The signs are the same. So the answer is 18 plus 4 is 22. There's your final answer. All right, let's look at number 33. Two x plus 3y over x plus 1 when x equals -2 and y equals +4. The first thing you have to do is place these numbers in there. So 2 times -2 plus 3 times 4 over -2 plus 1. So far, so good? What do you do on top? Let's treat them both separately.
You do a negative, so it'd be 4.
Very good.
And that would 30 times 4 would be 12.
And they're both positive, so it's +12. And on the bottom, well, here's the rule here. Are the signs the same or different? What do you do?
So it would be negative still because it's
2 is bigger, and then subtract the numbers. 2 minus 1. Yeah. Okay, the top becomes what? It'll still be positive. It'll be what? Very good. So the negative simply goes on. When you never want a negative on the bottom, so you put it on top. 8 divided by 1 is -8. You got it?
Yeah.
There you go. See, you just have to have confidence in yourself. You want to do some more? Let's do a little bit bigger ones. Let me see. Have you ever done this kind of problem? Or do you want to do some more of these plugging in numbers? Okay, let's pick number 29. Yeah, until you feel comfortable, we can do as many as you want. 3x squared plus 2xy plus 5y squared. Number 29. When x equals 2 and y equals 3.
Yeah. Okay, my 2's look like 3's, so that's one.
I had that problem. Yeah, that's why I always try to put everything in X's and Y's, because if I put an S, it looks like a 5. So yeah. No, so let's work this one out real quick. You got it right, but for the video, let's work it out. Anywhere I see an X, I put a 2. Anywhere I see a Y, I put a 3. Yeah, I can see why you put a 3, because you put a 3 there, subconsciously you're gonna put a 3 up there. So exponents first. 2 squared is 2 times 2 times 3. And we do another exponent here. 3 squared is no more exponents. You can't do anything inside the parentheses, so we multiply. 3 times 4. Since these are all separate terms, we can do them all at the same time. 2 times 2 is times 3. And then 5 times 9. 12 plus 12 plus 45. Very good. Very good. Oh, let's look at the formula question here.
They're gonna get me confused.
The conversion from Fahrenheit to Celsius is this formula here. What's the difference between Fahrenheit and Celsius? We use Fahrenheit. The rest of the world uses Celsius.
Why is that?
Metric system. America's, for some ridiculous reason, never wanted to go to the metric system. So the rest of the world progressed. All our engineers, all our scientists always use metrics. Even mechanics a lot of times use metric systems. But America still, for some ridiculous reason, doesn't want to convert all the machines over. So let's look at the first one. It's going to be the same process. Number 35. What if we had 50 degrees Fahrenheit? There. So that's where my F value is. So I put 50 in place of F. Okay, here's an important note that's not really. Hold on. I have to get this. Remember, this is 50 degrees in Fahrenheit. So that's what these are. These are actually in degrees. It's 50 degrees minus 32 degrees. The reason they use 32 degrees, because that's our freezing. When we say it's freezing outside, it's 32 degrees. So what we're doing, we first have to subtract 32 to get the real 0, and then we can do the conversion. So 5/9. 50 minus 32. Zero minus 2 you can't do, so you got to borrow 1. 10 minus 2 is 8. 4, 18. Yes. So it's 18 degrees. Can anything cancel on top and bottom? 9 goes into 18 2 times. So we have 5 times 2 degrees, which is 10 degrees Celsius. That's how you do the conversion. You pretty good with that? Okay, then let's see. This is actually the next section, but I want to see if you can do it here. Solve for F. Find me the conversion from Celsius to Fahrenheit. No, it's use this. Solve for F. No. I want you to, when you finish here, I want F to be by itself. I want an equation. I don't want number, I don't want an answer. I want an equation. So solve for this variable here. I want you to solve for F. Remember, it's an equation, right? So you have to solve for a variable. I want you to solve for this variable. How would you do it? What do you have to get rid of first? Since F is inside the parentheses, we have to get rid of everything outside the parentheses.
So get rid of
5/9. How do you do that? Since these are multiplied, we have to multiply by the opposite of this. What's the opposite of 5/9? 9/5. Both sides. Whatever you do to one side, you have to do to the other. So why do we do that? Let's look at here. The 9s cancel. And the 5s cancel. So we have 9/5 C equals F minus 32. Now we're trying to get F by itself. What do you have to get rid of?
32.
Yeah, the minus 32. What's the opposite of minus 32? Positive 32. So we add 32 to both sides. So the F is by itself now. And we have 9/5C plus 32. And there's the formula for Celsius to Fahrenheit conversion. And we'll go through more of this because that's what the next section is all about, is solving equations. So let's use this formula. Here's C. Plug it in there. Let's find Fahrenheit. What do you do first? We have a multiplication of two fractions. Before you multiply fractions, you have to see if anything on top cancels anything on the bottom. Yeah, 5 goes into 10 2 times, so it's 2 degrees. So we have 9 times 2 degrees plus 32 degrees. $18 degrees. Because that's, remember, so we started at 10 degrees Celsius, right? But that came from Fahrenheit being 50 degrees. So that's test it. So that's how we use equations and formulas to solve things. Okay. Let's go ahead and jump to the deep end. Simplify number 66. Four times 6x squared minus 3 minus 2 times 5x squared minus 1 plus 1 . Remember the order of operations.
What do you start with? Well, I would say print.
Yeah, when you're left to right, you have a parenthesis, so you have to do inside here. Can we do anything inside there? This is 6x squared minus 3. Can we combine those? No, because this is x squared, apples and oranges.
Oh,
This is x squared, this is not an x squared. You can't combine them.
so you,
So you can't do anything inside that one. So we keep on going. Here's a bracket. So we do inside the bracket, left to right. Here's a parenthesis. Can we do anything inside there? Can we add or subtract 5x squared minus 1? Okay, so we can't do anything inside those. So we have to do what? We have to get rid of them. So we can't do any special operations there. So we have to get rid of them now. Next thing is multiplication. How do we get 4 inside there? What do we do? Yeah, you call it, yes. Distributivity. Distributivity. A times x plus y equals a times x plus a times y. Yes, that's kind of rainbow. So positive and positive, 4 times 6 is 24, x squared. Well, I'm doing signs first. Positive times negative,
is. Negative.
right? Then 4 times 3 is 12. So that took care of the first one. We have a minus. But since this is a bracket, we have to do what's inside the bracket first. We cannot really remove the brackets until everything's fixed inside there. So what do we do inside there?
You do the rainbow.
Do the rainbow thing again. So 2 times 5 is 10x squared. Positive times negative, 2 times 1. So that took care of that parenthesis. We can't do anything in the first one. Now inside the bracket, we're supposed to do that. Can we do anything inside the bracket? We can combine like terms. Very good. Because 2 is bigger, so the answer is negative. 2 minus 1 is 1. Very good.
You still-
Well, we can't do anything inside there. We can't do anything there. So we have to get rid of the brackets. Well, we have, if there's no number in front of there, it's an invisible 1. We have 24x squared minus 12. Do the rainbow again. Negative times positive is negative 10x squared. Negative times negative, positive 1. Yeah. So we got rid of the parentheses and brackets. Whenever you get rid of parentheses and brackets, always do combine like terms. Can we combine anything?
Um,
Exactly. So 24 minus 10 is?
Positive because
Right. So it's positive what? (24 minus 10). Be a positive 14 x squared. And then we can do the constants. Is it going to be positive or negative?
negative.
12 minus 1. So the signs are different, take the sign larger and subtract the numbers. That's as far as you can go. And that was a pretty big, ugly one too. Actually, that's the ugliest one they had. Let's do a couple of these. Let's look at 86, 88, and 91. 86, 88. Anyways, let me write those down. So 5 plus 3 times x minus 4 equals 8 x minus 4 equals 8x minus 32.
Why is there so many equal?
Because what this one says is determine if it's true or false. If it's false, then fix it. Let's look at this one. So instead of looking at all these, let's look at this. What would you do first? Or ignore this, yeah. Right, you can't do anything inside there, so. Look at order of operations. Look at, you can't do anything inside of the parentheses, so you have this. That's what kind of operation?
Oh,
Right, multiplication before addition. So that's the mistake they made. So we first have to get rid of the parentheses, so we just do the rainbow. 3 times x is positive times negative. 3 times 4. Now combine like terms.
would be. It would be a negative.
Right? Be negative what? -7. What else?
Plus 3x.
Right. Can't do anything else? Yeah, so typically we put the x's in front. So this is how you write it. So in other words, the highest exponent and you keep on going down lower. So yeah, their mistake was they added the 5 plus 3 first. Number 88. X minus 0.02. 88. X plus 200 equals 0.98. X minus 4. I don't think we covered any decimal equations yet, have we? Okay. So whenever you have decimals as coefficients,
Then you.
no, actually, that you remember, glad you remember that. That's only when you multiply decimals. Here, because it's coefficients, remove the decimals. Because every time you multiply by a 10, the decimal moves 1 to the right. For example, 9 times 10 is 90. 9 times 100 is 900. And 9 times 1,000 is 9,000. Let's look at what happens to the decimal places. This is 9.0, right? Decimal's there. When I multiply by 10, I move it over one space. If I move it, multiply by 100, I move it two spaces. So the number of zeros is the number of spaces I move. I have to move this one two spaces. Same as there. So in order to get rid of the decimals, I have to multiply this entire equation by what number? I want to get rid of two decimal places. By 100, exactly. So I multiply, I have to do the same to everything. So I have 100 times x, 100 times 0.02, x plus 200 equals 100 times 0.98x minus 100 times 4. How many terms do I have in the original equation? How many terms do I have in the original equation? How many terms? A term is anything separated by plus, minus, or equals. Here's one term. This is another term because it's all multiplied together. Here's another term. And here's another term. So I got to put 100 in front of each one of these terms. That's what I did. Well, yeah, but now it's going to get a lot easier because we're going to get rid of decimals. So 100x we can't do anything with, so leave it there. 100 times 0.02 equals 2. Then leave the x plus 200 alone. 100 times 0.98 is 98x. 100 times 4 is 400. Now it looks a lot easier. So what's my next step? Exactly. So negative times positive is negative. 2 times x, 2x. Negative times positive is negative. 2 times 200 is 400.
And you divide 100 and 2x.
So it's 98x. Yeah, but yeah, actually, it goes even further than that. This is a true statement. But if we went further, let's see what would happen. So we have 98x minus 400 equals 98x minus 400. We have to, yeah, we can't combine 98 and 400. So how do we move 98 over? Remember, it's a process of opposites. Whenever you move, exactly, because I'm moving it, I have to get rid of it. So I change it to a minus. Very good. 98 minus 98 is 0. So I have minus 400 equals minus 400. That's called an identity. Reason it's called an identity is because in the original equation, no matter what X you put in there, it'll be a true statement. It has infinite number of solutions. Basically, we're doing two sections at once. This is still section 1, but we're also doing section 2 stuff. So whenever you work out this equation and it comes out to be 0 equals 0, that means it's an identity. No matter what you put in there, it'll work. Number 91. Three y minus 4, close parenthesis, minus 8y minus 1, close parenthesis, equals negative 5y minus 3. We can't do anything in the first parenthesis. So do we need the parentheses? If it's a first parenthesis and there's nothing in front of it, do we even need the parentheses? So we just drop the parenthesis because there's nothing in front of it.
But there is. Oh.
Yeah, you can't do anything inside there, so we have to get rid of the parentheses. What number is in front of here? Right, so negative times positive is 1 times 8. Negative, negative. 1 times 1. So let's see here. What happens here is this. Whenever you have a negative sign in front of a parenthesis, just a negative sign, all it does is change all the signs inside there. So if we see that, just change this to a negative 8, positive 1, and we're finished. Okay.
3y negative 8y.
Which is? Very good. So its answer is negative. 8 minus 3 is 5, 5y. And then equals negative 5y minus 3.
If you still kept going. So it would, we have to bring it to positive 5y.
Both sides, right? So those cancel.
3, make it a positive. Cancel out.
Perfect.
Now I understand.
Excellent. And that was the difficult stuff too.
Trouble with these.
And I really, really hope that you now understand much better what goes on. Okay, well, let's do a couple of examples here on 6.2. And we'll show you, because now what we're doing here is solving. So let's say we had 2x plus 3 equals 17. We're gonna do an easy one, and we're gonna do a big one. It's the same rules all along. And then next time we'll expand the rules. So whenever you have an equal sign and a variable, you're asked to solve for x. We do this by a process of opposite here, like you've been doing. We want to get the X by itself. So to get the X by itself, what do we have to do? What do we have to get rid of?
The 3,
Right, how?
make it as a, to the other side, -3, -3.
Right, so we subtract 3 from both sides. 17 minus 3 is?
No, 14.
Remember, it's opposites. That's a positive. I have to put a negative. How do you get rid of the 2? How is that connected to X? How would you read this? What mathematical operation is there? It's so, again, what's the opposite of multiplication? So we have to divide by 2. I'm sorry, I put up there too fast. And whenever you solve for the equations, always at the very end, check your answer. So we had 2x plus 3 equals 17. We said x was 7, so plug it in there. Does the left side equal the right side? If it does, then it's the right answer.
So 2 times 7 would be 14 plus 3.
Yeah, so 17 equals 17. That's true, so that's a good answer. Let's look at this one. I'll put 4 times 2x plus 1 equals 29 plus 3 times 2x minus 5. And this will be our last one.
Plugging for, wait, yeah.
You don't plug in anything. There's nothing to plug in. So what do you have? We're solving, there's an equal sign. So we're solving for x. What do you have to do first?
Can't you do the rainbow?
Yeah. Because whenever you have to get rid of the parentheses, so you do the rainbow. 4 times 2. And then positive is positive. 4 times 1. 4. Equal sign. There's a 29.
Do the rainbow.
Mhm. Yeah, because positive times negative is negative. 3 times 5. Whenever you get rid of parentheses, what do? Combine like terms. So can we combine anything over here? No, so we'll leave that alone. How about over here? Yeah, we have 29 minus 15. All right, so far you're doing great so far. Now, you notice we have x's on both sides. Whenever you have x's on both sides, always move the smaller x to the larger. Because that way you'll always have positive coefficient.
The. So move the positive 6x and makes it 2. And then.
Excellent. Yes, beautiful. So I subtract 6x from both sides.
Then it would be 2x.
Plus 4. 14. You have all the x's on one side, move everything that's not an x to the other side.
Negative 4, so then it minus 4. It would be, then we divide.
Very,
4,
very good.
then 2 to 5, so x equals 5.
Perfect. And that was a big one.
Now I get it. Now I get it. I would struggle with this one.
That is excellent. You did a fabulous job there. Because then we're going to have, let's look at fractions. Fractions are no different than what, I guarantee you, when we do this example, you'll have no problems with fractions ever again. 3x over 2 equals 8x over 5 minus 4. When you have fractions and an equal sign, here are the steps. When you have fractions and put over there, equal sign. Step 1. Find the LCD. What is the LCD? What does it stand for, LCD? Least common denominator. No, so that's it. So what's asking here is this: what's the smallest number that both of these fit into? In this case, since they're both prime numbers, just take them both and multiply them together. The LCD is 2 times 5. Yeah. So once you find the LCD, the second step is multiply the LCD to each term. So we have 10 times 3x over 2 equals 10, 8x over 5, 10 times 4. So far, so good? Or am I losing you?
No, I'm just writing down.
Okay. So yeah, each one of these terms, I just put a 10 in front of them. The third,
So if we get LCD, like the bottom numbers of the fraction?
Yeah.
Okay.
because that's the smallest, in this case, but if we had like 21 and 15, let's say our denominators were 21 and 15. Well, then we have to break them down. 21 is made up of 3 times 7. 15 is made up of 3 times 5. They both have a 3 in common. So this one has a 5. This one needs a 5. This one has a 7. This one needs a 7. So that's your LCD. So that's what you would do if you needed to. Okay, so third step, once you multiply them, cancel. or reduce. So 2 goes into 10 how many times? The 2 on the bottom goes into 10 5 times. Because yeah, if you notice, if I have a 2, I get rid of the 2, I have a 5 left over. If I get rid of the 5, I got a 2 left over. So let's see what we have left. I'll just write what I have left. Does that look ugly? Which one of these looks uglier? The top or bottom? Yeah, but they're exactly the same equation. All we did was get rid of the fractions. Now we do what we've been doing. Bless you. 5 times 3. So now you multiply. So 5 times 3 is 15. That's, you multiply to get rid of the parentheses. Two times 8. $16x, and then negative times positive, negative 40. Yeah, because as I said, always do signs and numbers differently. And then the last step is solve for x. And it's always those 5 steps. Now, there's no combining like terms. Remember what I said, whenever you have x's on both sides, which one do you move? Always move the smaller to the larger. Right, so what would be on this side? Yeah, because anytime you add a number and its opposite, they always equal 0, which is what we're doing. 15 negative 15 equals 0. 16 minus 15 is 1x. Well, yeah, since you have the x's here, move. So you add 40 to both sides. $40 equals x, or x equals 40. That's your answer. So the only thing different there is we have to first find the LCD to get rid of the fractions. Everything else is the same, no matter what the fraction is. Okay, it's 11 o'clock. So how do you feel about that?